Alright, in this video we're going to be looking at some things you need to be aware of when you're dynamically allocating memory in a constructor. And here I've got a hero class. I've also got a few other classes here. We've got a weapon class, and derived from weapon I have a sword class. And inside my hero I want to be able to give my hero a weapon. And I'm going to make that a pointer, and that way I can assign him different weapons that are completely independent of the hero itself. So initializing here, it's a null pointer, but in my constructor I'm going to assign this hero some default weapon. So I'm gonna print out that the hero has been constructed. This is just to show that the constructor is working. I'll give him a name default hero, and then I'm going to assign a sword to that weapon pointer. I do have sword included up here at the top. So weapon equals new sword. And we can give this a name. Call this the wooden sword. When I use new in a constructor, then it's going to create this object out on the heap separate from the hero itself. And so if I delete my hero, or my hero is otherwise destroyed, then this sword is going to still exist out on the heap unless I delete it down here in the destructor. So this is the line you need to add to the destructor if you want your dynamically allocated object to be cleared when the original object is cleared. So that's the first thing you need to think about. You will almost always need to do this. There's some cases, such as in video games, you may have an object that uses a texture. A texture is an image as it resides on the GPU. But let's say we had a bunch of trees in our program. They all share the same tree texture. Then maybe if we delete one tree, we don't want to delete that texture because then all the other trees would lose their texture. But it's just something to be aware of. In most cases, if you dynamically allocate memory in the constructor, you're going to delete it in the destructor. The next thing you need to think about is the copy constructor. And copy constructors are used anytime an object is created based on another object. Anytime we create an object copying an original object. And so that's what we have here. Some object is being passed in. We call it orig for the original. And then normally you're going to do things like this name equals the original name. But what about our sword here? If we say this weapon equals the original weapon, all we've done is copy the address. Copied the address of the original object. And the book calls this a shallow copy. And so if we copied our heroes, let's say we have two heroes now, they're both sharing the same sword. And that may be okay, but it's probably not, because if one of those heroes is destroyed, then the other will lose his sword. Or if one hero, say, sells his sword, then the other hero would be without that sword. So we may want to give him his own sword. So we could say this weapon equals new sword. And we could make it whatever you want it to be. But it needs to be its own independent object. Just to show that there's a difference, I'm going to call this a stone sword. If you do not override your copy constructor, there is one that exists. It's hidden in the background. All it does is a bit-by-bit copy. So it just copies everything from the original. And if you've got pointers in there, it's just going to copy that address. And so if you've dynamically allocated memory, sometimes you will want to allocate new memory for your cloned object. And the same thing that goes on in the copy constructor will happen if you use the assignment operator. So we're going to overload the assignment operator. That's the third thing you need to remember. So in my header file, I'll say operator equals hero. We'll put original in there. And this is just like the copy constructor as far as what goes on with the assignment operator. So we can define that here. And then for the definition, I can just copy what I have in my copy constructor. And that way, if I copy with the copy constructor or I copy with the assignment operator, those cloned heroes will have their own independent weapons. All right, let's step over into main and see how this works. I'm going to create a hero. I'll call that hero 1. Well, before we get started, let's go back and put cout statements inside these constructors. So I'll put cout hero copied. And then for the assignment operator, I'll put that there, just something there to let me know which one is being used. I'll show you why I do that here in main. So you should see hero constructed right there. Let's make sure this works. Okay, hero constructed, that works just fine. Now, if I want to clone my hero, or copy my hero, I can say hero 2, and then I can pass in hero 1. And this will execute the copy constructor. We can see hero copied. Now there's another way of doing that. We can say hero 2 equals hero 1. And you would think because we're using the assignment operator, then that would invoke our overloaded operator, but it doesn't. This also uses the copy constructor. So we see hero copied. So when then is the assignment operator used? The assignment operator is used when we have existing objects and we want to copy one data from one to the other. So if I were to do hero 1 equals hero 2, then I'm using my overloaded assignment operator. And we can see 2 heroes were constructed and then the assignment operator was used. And now I've just realized I have another problem here. I have just created a memory leak because hero 2's original sword has been replaced with a new sword, but the original sword was lost in the matrix. So we need to make a change to our assignment operator. We need an if statement that says if this weapon does not equal null, we need to delete it first. And then we create the new weapon. We don't have to worry about that with the copy constructor because we know that the original, or not the original, but the object that we are creating is going to have a null weapon. And we said that the name would change, but if you didn't want that to happen, if you wanted it to be exact replica of your original object, you can just dereference these guys and say this weapon equals original weapon. Dereference both of those, and then that will copy the information from the original weapon over to the newly created weapon. So even though I put stone sword here, if I'm copying a wooden sword, it's going to be a wooden sword. And that takes care of our memory leak.